Let's take a look at Ohm's law. Ohm's law states that the current between 2 points in a circuit is directly proportional to the potential difference or voltage between those 2 points. By including the total resistance in a circuit, we are led to an equation. This is I, or current, is equal to V, or voltage, divided by resistance. This is the equation most commonly cited as Ohm's law. Now, current is measured in amps, voltage is measured in volts, and resistance is measured in ohms. Using algebra, we arrive at 3 equivalent equations. The one we first stated, which is I is equal to V divided by R, V equals I times R, and R equals V divided by I. These equations can lead to some general statements about these quantities in a circuit. As we increase the voltage in a circuit, we also increase the current. The converse is also true. As we decrease the voltage in a circuit, we decrease the current. Also, as we increase the total resistance in a circuit, we decrease the current. Or if we decrease the total resistance in a circuit, we increase the current. Let's take a look at some simple examples of applications of Ohm's law. Let's say we have a circuit that has a potential difference or a voltage of 12 volts and a resistance of 5 ohms. And we want to know what is the current in that circuit. In this situation, we can use the equation of the current being equal to the voltage divided by the resistance, or I equals V divided by R. And we can substitute in the values for these variables to determine the current in this circuit. So our current will be equal to 12 volts divided by 5.0 ohms. This gives us a current of 2.4 amps. Let's look at another example that's slightly different. We want to know how much resistance must be in a circuit if it has a voltage of 14 volts and a current of 3.3 amps. We'll use the equation of resistance is equal to the voltage divided by the current. Or the resistance is equal to 14 volts divided by 3.3 amps. This gives us a total resistance in the circuit of 4.24 repeating ohms. It's important to note that each of the 3 equivalent equations of Ohm's law can each be derived from one equation of Ohm's law. Again, we do this by using simple algebra and isolating the variable of interest. So we don't really have to memorize 3 separate equations. All that is needed is to understand one equation and then use algebra to rearrange it or isolate different variables.